Good morning, good afternoon, and good evening from wherever you may be joining us. Welcome to our webinar today, where we'll be showing off the incredible technologies ORPALIS has developed over their rich, almost 20-year history. As you all know, ORPALIS recently joined the PSPDFKit family, and we are super excited to show you the possibility of what's to come with a combination of our product offerings. By combining these two incredible teams, we are able to strengthen the document foundation that so many enterprises, startups, and businesses currently rely on today. With the combined offerings, we will now be able to not only offer the best front-end user document SDKs on the market, but now be able to offer some of the most robust, feature-rich back-end processing libraries on the market as well. With this merger, we are now positioned to cover the entire spectrum of the potential document needs in an organization going paperless, supporting just about any document file type, whether image, Office, PDF, static, or dynamic, as well as help those brave developers to enable the full gamut of use cases, from building apps on a server for backend processing, to cleaning up scanned documents imported to a system, to utilizing one of the best OCR engines on the market, all the way to building innovative collaboration and signing solutions for end users. And the list goes on, I promise. By adding ORPALIS technology to our already existing robust document foundation, developers, no matter their preferred language or framework, will now truly be able to build the applications of tomorrow, today, and finally start fully realizing the promises of the digital revolution. This merger not only enriches what we were already able to offer before, but extends and enhances the platforms we currently serve, especially on the Windows ecosystem, and particularly to .NET, a popular framework in the enterprise space. We'll be adding the ability to read and create barcodes, support CAD, enable PDFA conversion, enable scanning, and other crucial image processing and filters. Further, the merger with ORPALIS's OCR, key value pairing, and automatic document recognition sets us up uniquely for the future ahead as we continue to pursue the technology that enables every document to live in a digital medium. We have already begun researching what possibilities lie ahead after that watershed moment and dare to get the world thinking about what's beyond PDF. We're super excited for you to be here today to learn a little bit more about what we are building together. We also want to thank you for your business, as we would not be able to be in this moment today without the incredible support of customers like you. With that, I'll hand it off to Elodie to kick it off. Hold on tight.
Hello, okay, so I'm going to share my screen. Okay. All right. So hopefully you all can see my screen. So before we start the demos, a brief overview of who we are. So ORPALIS was built around the GDPicture.net SDK, which was first released in 2003. We offer SDKs and end-user solutions to overcome the daily challenges of electronic documents, whether you're a developer or an end user. We're also board members of the PDF Association, and in this context, we've helped organize many events and promotions around the format. Today, we're going to focus on the technologies we deliver in our SDKs. So our technology covers the entire electronic document lifecycle, from acquisition to archive. In total, we offer more than 3,000 functionalities through many different forms and platforms. Today, most people know ORPALIS because of GDPicture.net. GDPicture.net is a set of enterprise-grade intelligence document processing SDKs. After more than 15 years of continuous research focusing on innovation, it has become the most comprehensive SDK in the market for PDF, OCR, barcode, document imaging, and formats to build Windows desktop applications. DocuViewer is our universal HTML5 viewer and document management kit. It offers controls for ASP.NET. With DocuViewer, you can view, annotate, and manage any document on any device and browser through a fully customizable zero-footprint HTML5 Ajax viewer. Passport PDF is a cloud ecosystem offering unified API and apps for all platforms. You can create your document processing desktop, mobile, and web application on any operating system with a wide variety of REST APIs. It's difficult to give you an overview of all our technologies in such a short amount of time, so I'll briefly summarize the main features we provide in our toolkits. So what's in our PDF SDK? So all the features you need to view, edit, and convert more than 100 document and image formats to PDF. Our collaborative features include annotation and comments, form field support, and PDF editing. We offer highly innovative hypercompression and optimization technologies that you will see in a minute. With our toolkits, you can tag your PDFs and secure them with encryption, digital signature, redaction, and PDFA conversion and validation. Our OCR engine benefits from a hybrid approach that includes heuristics, mathematics, and machine learning capabilities. We've been working on it for the past 15 years. It automatically adapts to the document and searches for the right approach, making the best use of available resources thanks to built-in multi-threading support. Our OCR technologies also cover optical mark recognition to recognize checkboxes and exam forms, magnetic ink character recognition to read banking checks, machine-readable zone for passport and visas, automatic document recognition for document classification, key value pair and table extraction, and other special context OCR requested by our customers. Regarding barcodes, we provide 1D and 2D barcode reading and writing features. You can see on the slides the different barcode symbologies we support. They cover the needs of all industries that rely on barcodes, so retail, transportation, postal services, shipping, healthcare, and more. Our imaging SDK include fully featured viewers, universal scanning and printing capabilities, image processing functionalities, and filters to clean up, repair, and enhance the quality of digital documents. These filters are, for example, useful for better and faster OCR, barcode detection, and compression. Finally, we provide advanced document conversion capabilities for over 100 file formats. If we look at our Office formats converter, for instance, our goal is to make it fast, secure, and easy to use. Office format support in our SDK is thread safe and independent of applications like Microsoft Office and OpenOffice. There is no need to add any third-party plugin or software to manage your documents and risk security breaches. Finally, you don't need to set up permissions to work in an environment like ASP.NET. And now I leave you with Mathus and Loic for the demos.
Hi, everybody. I will quickly share my screen. Okay, so you should see my screen. So hi, everybody, and thank you for joining us on this webinar. My name is Mathus, and before we joined PSPDFKit, I worked at ORPALIS as PDF specialist supervising our PDF toolkit. And I would like to provide you a sneak peek into some of the PDF technologies we have been perfecting over the last few years, and we are truly proud of. So I would like to focus on two features of the toolkit, which are hypercompression and PDFA conversion and validation engines. So let's start with the hypercompression. The hypercompression stands for our innovative mixed raster content compression engine. This engine is producing spectacular results by automatically adjusting the trade-off between quality and compression rate to provide top quality PDF MRC documents at the lowest possible file size, basically. At the core of the technology is our industry-leading segmentation engine that divides input image or document content into separate layers of binary compressible text. You can see that on the graphics as the layer number 2. Background, which contains continuous tone and image features of the document. This is basically the original document with extracted or without the text layer. This is the number 3 on the graphics, and basically the foreground layer, which acts as a chromatic channel for the binary layer. So if the text needs to be changed, we will color it with this layer, and we can save a lot of size by this technique. Using the advanced image analysis, we are then determining the most efficient compression techniques for each layer. And finally, we are composing these layers into the output PDF document using specific rendering instructions. This is a specific feature of PDF that allows this advantage over standard images, where basically you can only use one compression algorithm or technique over the whole image, while PDF allows you to use the composition, blending, and these kind of techniques to blend different kinds of images together and form one single page. The results of this effort basically are considerable document size reduction. We can reduce any 300 dpi color document page to a 20 to 60 kilobyte file, which leaves us with reduction in file size by about 90 to 95% in general, but we can get up to 98% in some cases. I will demonstrate this shortly. And we offer superior contrast and color saturation preservation and automatic document cleanup with no perceptible data remove or alteration, leading to improved OCR process recognition speed and rate if necessary. In some cases, the engine is also capable of improving the final quality of some lower quality documents by sharpening and similar techniques, again, improving the next phase of the document life. I have prepared some quick demos for you, so I will show you how easy it is to set up the hypercompression using our toolkit and see the results of the process with some comparisons. So I am quickly opening now the Visual Studio. I have prepared a very simple project here. Basically, just standard Windows Forms application. We have added the GD picture assembly that you can just download and put it straight in. And with just few small lines of code, so you can just register a product, and with just 3 lines of product, you can 3 lines of code, you can start processing the document. I would like to notice here that this is basically just one of the possible uses or how to use our mixed raster content compression technology, because it can be used on various parts of the toolkit, like by adding page to the PDF or in some of our end user products. So yeah, the GD picture reducer class is basically just one of those uses, which is very simple. So as you can see, we are utilizing these lines of code to process 3 documents from our input, which we have prepared 3 documents here. I will quickly run the process, just licensing information, and we are running the MRC demo. You can see in output, we will start seeing the process documents popping up, and we will be finished very soon. Boom, we are ready. And now we can start comparing the documents. So as you can see, the first document is very rich on text and images, is very funny composition. If you would be compressing this document, as you can see, the fidelity is pretty good on the document. If you would be compressing it with standard techniques, you would be probably getting something like this. So you would get this is the result of simple JPEG compression. You will get artifacts around text. The images will be very blocky, and you will basically lose possible information in some details of the document. You can compare it with our results. You can see that the document is mostly staying the same. If you zoom in, the text is still very sharp. Documents are not blocky. They are a little bit blurry, but they're still very usable. And if you will look at the details on the document, you will see that we have recognized the detailed text on some graphics, and we have preserved the information to make sure that we will get top quality document. The interesting part comes when you compare the size of the original document, which is 1.6 megabytes, and the resulting document is right now 68 kilobytes. So that itself is about, I believe, 95% compression. So very nice results. As you could see, the quality has stayed very high. We have another document which is classic scanned form document, and this one features, for example, barcodes. Again, the document in originals is roughly 2.8 megabytes, and if we check the output document, again, quality is very good. The barcodes are processed and optimized to be readable by machine reading technologies, and again, we have compressed the document to 98 kilobytes. The most extreme case I can show you is this document that basically is 25 megabytes as original. The resulting document is just 60 kilobytes, so we can achieve pretty high compression rates with this technology while retaining very high quality of the documents. Okay, and that would be it for the MRC demo, I believe. So we can get back to the slides. And the next one, the next feature I will be talking about is the PDFA support in the GDPicture PDF Toolkit. Just briefly to talk about what exactly is PDFA. The PDF document format is very versatile and allows the creator of the document to utilize many different features to construct the document. Some of these techniques proved rather problematic when the needs for document archiving emerged because of, for example, documents that didn't have embedded fonts were showing different. The best scenario is showing different graphics but retain their information. So there was a different font, but the information was retained. But in extreme cases, the missing font can completely cause the loss of information on the document. There can be problems with non-calibrated color spaces, and you can lose information in some blending phases of the document as well, especially when printing the document. So these problems basically sparked a movement that formed the PDFA as ISO standard that specifies how the PDF document needs to be constructed and which features should be utilized in order to ensure the documents are suitable for long-term archiving, which is more and more frequently utilized across the world by government, industry, academic and financial institutions, etc. But there was another problem, and basically some documents may claim that they are PDFA compliant, but in reality there can be hidden errors. Basically, the document does not can in some cases the document can be trying to be conformant to PDFA, but errors in the process can basically completely make the document unusable. So basically, every document needs to be validated, and the institutions basically that are archiving the documents needed a way to validate these documents before accepting them. So after several closed source and proprietary validation solutions, so the Open Preservation Foundation, PDF Association, and Digital Preservation Coalition created the VeraPDF project, which had a goal to basically build a precise open source PDFA validator that would act as a default go-to tool that any institution can use to validate PDFA documents. VeraPDF project is great on its own and works very well, but for our purposes, there were integration problems. It is based on Java, and as well the performance issues we could not overlook because it basically was slow for server processing, stuff like that we needed. So we decided to build our own PDFA validation and conversion engines. With respect to the VeraPDF project, we decided to make it our benchmark when it comes to precision. and improve significantly on the performance utilizing our own processing technology, which we already had. So our efforts basically resulted in super quick PDFA validation and conversion engines with minimal memory footprints, while keeping up with the VeraPDF in terms of validation precision on real-world documents. I will quickly demonstrate the conversion and validation features on the demos that I have prepared here now. So again, I'm opening the same application. The second button basically is utilizing this part of code, which is this one, which is basically just iterating through my input directory and basically converts every file in that directory into the PDFA. So I will quickly run that. We can open the output here, and we should see the files popping in already. So the processing has started and should be finished. It's around 30 documents. Didn't want it to spend much time on it. And okay, I think we should be done now. So to check the document, basically, if we look at the inputs, we can quickly open VeraPDF and choose, let's say, the conversion and input documents. And let's take the first one, and VeraPDF will quickly show us that the PDF is not valid PDFA. Now, if we open our document, the Acrobat, first off, will tell us that the document is further wait is valid, verification succeeded. We have PDFA 2B document, and we can also open it up on VeraPDF and execute. And we can see that the profile is valid. We can open the report, and as we can see, the file is passing the validation now. So the file was successfully converted, and I would be able to go through all of these files. You can believe me, all of them would be valid by VeraPDF standards, because, as I said, we have used it as a benchmark for these. The one note is that we have basically processed about 39 files in few seconds on one thread. We can run this on many threads, and the processing can be super quick for server use as well as for desktop use in Office. So very good tool. We can also go to the validation demo quickly. This is this one. So basically, I have again prepared something here, which is these are some random PDFA documents. They claim to be PDFA valid. So we will go through them. We will run the validation demo, and we will quickly show the result of our validator. The first document we are checking is by the our report is valid PDF, where we have 0 failed checks. We can again go and confirm that on VeraPDF if we want. Execute, and as you can see, the validation of single file is taking quite a long time on VeraPDF. Notice that we had this validation ready in split second on our engine. VeraPDF is still running it. I'm sure it will be very soon ready. Sorry for the wait. And we can see that file is compliant. So that is the same conclusion as with our validator. We can quickly check another file. Notice how long it will take. Boom, we have another file validated, and this document failed the PDFA validation. We can check the file, which is 008 something. We will choose the PDF. validation input. This one, open, and let's validate it. This one was quite quick. VeraPDF, good job. And we can check the report, and we can see that VeraPDF is reporting as well that the files failed. It has some problems in the XMP metadata, which is basically, again, correlating with our findings that we have invalid XMP metadata on the file. And again, I would be able to go through the files but there's no point in doing that. And that would be basically it. That would be the conclusion of my demos of the hypercompression and the PDFA validation and conversion. And I will now pass the word to Loic, where he will show you some nice OCR and intelligent document processing technologies of ours. Thank you very much.
Hello, everybody. Thank you, Mathis. It was very good. I am Loic. I founded ORPALIS around 15 years ago, and I was constantly involved in research and development activities with a focus as last years on building intelligent document processing capabilities. As a result, GDPture technologies now offer a wide range of features permitting to transform undefined and semi-structured information into usable data, such as automatic document classification, OCR and PDF OCR engines, check, barcode, MRZ reading engine, table processing, and lastly, new key value pair detection. Now let me illustrate this with a couple of very short demos. I'm opening the application. Okay, so the first demo is about MRZ. This is the ID card of a famous developer. GDPture includes a specific engine to quickly detect and decode MRZ data, which has this stuff. MRZ content can be found on driving license, passport, visa, and other ID and traveling documents. It contains mandatory and optional data. We start a recognition. I'm using first the good context, read page. Okay. So as you can see, the processing time is fairly low and the accuracy is excellent. Around 100 milliseconds. Well, we will try to do better. With extracted lines, you can obtain information such as name of the holder, date of birth, sex, expiration date, and so on. Let's now switch to a document OCR demo. Using the good context, OCR start. This is basically an invoice. The processing time is a bit high, don't know why. So OCR has three major competitive differentiation. It has a very unique layout analysis system. It is backed by different recognizers with voting mechanisms, and it has a strong set of document understanding capabilities. About recognition, the engines recognize text quickly with high accuracy. We have spectacular results on business documents. About layout understanding, the engine is able to correctly identify tables, fields, paragraph, line, word, and character with high segmentation quality. For example, if I want the result of character segmentation, you can see each red rectangle is basically a bounding box of a glyph or a character. We have super good result about that. So we can switch to Word, for example. So we are still seeing lines. Words are separated here. If you want text line segmentation, it's here, and so on. One interesting features we recently introduced is table detection. As you can see, in no time, we're able to detect tables and decode their physical structure and get the internal content. We are pretty much high accuracy on almost any kind of table, which is cool. And lastly, about document understanding, which is for us beyond OCR capabilities, we are able to understand the information with labels and values in a document, extract them and qualify the value in one instant. To illustrate that, I will ask basically the toolkit to give me the pair of key and value, KVP, okay. The green rectangle is surrounding a pair. The red rectangle key of this pairs, and blue rectangle the values. So we are doing association between key and values. I will show you in a banking document of which kind of result we can obtain. As you can see, in less than a second, we can extract all the information and obtain relationships between each key, each value, and obtain also the qualification of each value. For example, here we have something which is an international bank account number, if I remember well. So the semantic definition in the document is IBAN, which is correctly detected as is. The content is here, which is correctly recognized. And the type of the data is IBAN. We have a lot of different types. I will not enumerate them. But I guess you can imagine what we can do with such capabilities. Another example in an invoice, KVP, for example, starts. So the engine is able to process invoice as any kind of document. Basically, we are completely agnostic. We are using mostly unsupervised approach for pretty much everything. So if I zoom, for example, in this isolated table, you can see the relationships were correctly established. And the next step for such kind of document with this document and the features we have is to build an invoice processing system, which is quite useful nowadays. And that to say, building an an invoice processing system is fairly simple with this technology Warframe. Okay, I'm done with demo, so I guess it's question time now. I will start to share my screen and
Yeah, I think someone asked a question about OCR and forms. So does the data come out unstructured, or there is a way to structure it?
Not sure to understand, but basically what we can do is to detect the structure of any kind of document and provide this information through the Ocr Engine. So in input, we have unstructured content, and as output, you have the structure that we have decoded from this input content.
Yeah, my understanding, Loica, the question is if you're just using the OCR engine and you're not using key value pairing or table extraction, does the data come out unstructured? And from my understanding, if you were just trying to OCR a document to understand the characters behind it, it would be unstructured. but then if you add key value pairing on top of it, we can associate type, category, things that you were showing in the second part of the demo. Okay, I don't think there's any other questions. Hold on. Will this enable us to detect fields in a form and automatically assign intuitive IDs to the forms based on the text in the document relating to it?
Absolutely. This is the purpose of the key value per engine we have, which is not template based. Basically, it's working with any kind of document. So it's discovering the structure of the document and is able to do association between value and keys or labels.
Does that answer your question, Martin? Okay. All right, awesome. We got a little bit of more time if there's a couple more questions. If not, we can wrap up. Okay. You can respond. There's also a recording of this that will be sent out via email. So for the people that weren't able to attend live, you can watch the recording. You can also always reach out to us at sales@pspdfkit.com, or you can go to gdpicture.com as well and contact sales there. They'd be happy to answer any of your questions, anything at all. Thank you, Loic and Matoush and Elodie, for doing the demo. It was great to see the technology. Thank you all for attending, and I hope everyone has a great rest of your day. Thank you. Goodbye.
Thank you.
Thank you, guys. Bye.
Bye.
Goodbye.